everyone. The presentation was initially intended for 2 speakers, but Eric Fiol could not come here today, so my apologies for this. I'm Paul Irola, and we are working with Eric on mobile banking security, and I'm going to give you a few results about what we found. Here is the agenda of the presentation. I will first introduce the background. In fact, all our work has been done under the OpenDAFI project, and I will present it. Then I will explain, detail our tool that we use to analyze application, and as an appetizer, we will see the Facebook application in details and what it do on the phone when you install and use it. Then, at last, we will present the global result about all mobile banking application, and especially the differences between Asian and Western mobile banking. After this global perspective, we will see the detailed analysis of 5 applications and what we have discovered. So, the OpenDAFI project is a fork of the DAFI project, which is the development of a sovereign antiviral system for Android, Linux, and Windows. It is done by the ESCUA Cryptology and Virology Laboratory. It is partially funded by the French government, and I will only speak about the Android part of the project. So, one of the key features of the OpenDAFI project for Android, it's the only application you can install on the phone come from a secure market. So the application from this market are fully analyzed. They are certified to be compliant with our trust policy, and they are signed with our private key. So you cannot install an application that is not signed with our private key. We rapidly came to the conclusion that an application not being a malware is not a sufficient information to be considered a trustworthy application, because the data leakage, the user tracking capabilities, and the vulnerabilities are a real motive why you don't want to install even a genuine application on your phone. So the problem evolved from not being a malware to be trustworthy. And we came along 4 rules that an application must follow to be considered trustworthy. The first one is it does not contain hidden functionality, so it includes malwares and backdoors. User information connection must be motivated by explicit functionality, so it limits the user tracking capabilities. Web communication involving personal data must be encrypted, and the app does not contain non-vulnerability. So the policy covers all the major problems we can find on an application. So, why mobile banking? The fact that most of the banks have now mobile banking application, so they are forcing their users to move toward mobile banking. And because mobile applications are not a very mature technology, there is always a risk that this application becomes the weakest link to attack the user or the bank. Moreover, our money is obviously a serious business, as well as our privacy and confidentiality. So we expect mobile application to be at the top of security and confidentiality. Most of the banks have been contacted to provide all the technical details about what we found, but just a few have answered. So now we wait for the bank to contact us after the meeting. So we have designed 3 tools to achieve our goals. The first one is an Android malware detector, and based on data mining and machine learning. It also performs a static analysis of the application and produce a report that supports the manual analysis. The second one is Panoptes. It's a dynamic analysis tool. It intercepts HTTP and HTTPS communication and build a report that also help the manual analysis. The third one is an Android application web crawler to collect new malwares on the wild. These tools are non-public at the present time, but we are working to release it on the incoming years. So, Agile reverse the application, extract a lot of characteristics that we use for machine learning and that are also useful from a static analysis point of view. It generates a static analysis report from these characteristics. I will show you the Facebook static analysis report. So, can you see? Yeah. So, we see all the permissions that the application requests. So, Facebook uses lots of permissions, and we detect also non-risky behavior and risky method calls. So sorry, all the titles are in French because this report is not intended to be public. So this table is lists all risky behaviors, and this table lists all risky API calls. So this code happens 2 more times in malware than in a regular application, and it's why it is interesting to list it. So when we want to see where a feature is used, we just click on this feature, so the dynamic code loading from a DEX file. And it lists all the classes that use this feature. We can click on it, and it opens the reversed code of the application where this feature is used. So sometimes the Java decompilation does not work because it's not 100% guaranteed. So it prints the smally code, which is human readable language for Java byte machine code. So the next tool is Panoptes. We see that static analysis is not sufficient. We need dynamic analysis to see what is really executed, because there are dead code and untriggerable conditions. So all the code is not always executed. The idea is that network communication is the bottleneck of all major behaviors. So we design a man-in-the-middle tool that captures all communication between an app and the web. The tool opens an access point that the phone connects to it, and it's how we do the man-in-the-middle. I told you that it can get encrypted communication. So in fact, as we control the phone, we put a fake certification authority in the phone. So the tool certify on the fly the request with our custom certification authority, so the phone actually believes it is a legit communication. It's a simple, when it's just simple material, your regular computer will do it. The next tool we are presenting you is Tarantula. So when we on the malware detection problem, we started with a little database of classified application, but this database revealed itself to be too small. In fact, we rapidly came to the conclusion that a large database of classified application is the heart of the antiviral game. So it's a subject rarely explained or detailed in security paper, but it's what gets you from a universal perspective to a business perspective. You cannot have a really viable and operational antivirus if you have not built a large database of malware. So the question is how to populate such a database, and how do the others make it? Several universities share their malware. I gave you some links and some websites also, but it is not sufficient. And in fact, our guess is that antiviral companies mainly get their samples from clients and intercompany exchange, and it is a way we can't mimic because it means you have to be in the business to be in the business. So we search for freely. Yeah, it's not very. You can. I'm sorry, you can really see this slide, but the slides are available, so you can check it later. So this is the structure of Tarantula. We designed an application web crawler to massively download application. We take them from different sources like torrent, wild FTP, alternative Android market from different countries, China, USA, Europe, and also the Google Play Store. Let's start the detailed analysis with Facebook as an appetizer. So we already know that Facebook collects information submitted by a client, by users, excuse me. But what about users' information collection that without the user knowledge? And what about information that are stored in your phone in plain text? Because we have a project in our lab that shows that any clear plain text data stored in the phone can be stolen in less than 1 minute. It's a project done by Eric Fiol and one of his students. I'm going to show you a video of this. So we have a little device, a dongle, that can interact with an Android phone. So the scenario is the victim is at a cafe, and the attacker is just behind it. He stole the phone in his pocket and connected to his dongle. The dongle interacts with the recovery partition of the phone, so it can affect lots of Android phones. And in less than a minute, it steals the plain text data stored in the phone and reboots the phone. So if Facebook let lots of information on the phone, it can be easy to get them. So we have installed the Facebook application and connected to my personal account. After some basic navigation, we get all the data created locally with the following command. You can do it at home with your own phone if it is rooted. So we get all data, and after reading it in binary mode, you will rapidly get some pattern of interesting data. And so the next thing to do is to design some regex to list all of this data. So here is a regex to get the contact list and all of his informations. So here it's all my friends. You can see it's their friendship status, the city where they live, or at least the last city they provide, but it is not over. You can have also all private messages that you have with your contacts since the creation of the account, of the Facebook account. You can get all the photos, so the photos that your friends share with you, and obviously all your private wall content and many other private and non-private data. So, in fact, you have almost all information that when you connect with your accounts. So, if an attacker wants to steal your data or know something about you, and these things are in your private Facebook account, like the messages with your friends, it does not necessarily need to know your credential, but have a physical access to your phone. We looked also for the request that Facebook sent to their server and other servers to see if Facebook was leaking some data. So I will show you the panopticon graph of Facebook application. So it's the graph. You can see all servers that are contacted when you connect to your account. So it's lots of servers. And this is a typical request that Facebook sends to their server when you connect it. So you log in, and it sends a very, very, very long string in a post request. You see all the metadata and the content. So it's a very, very long request, and it is not the only one. And here I can see all the strings that are sent to the Facebook servers. So if I list all this string, it became very, very creepy, as you see it. So it's a 1 kilometer request. Okay, so it's not very human readable. So you need to another reverse procedure to know what is really sent. So I will show you the procedure to reverse the ultra complicated post request. So you escape your URL code recursively. After you've done this, you parse the output as a JSON object. But in the JSON object, all variable can be a string representing another JSON object. So until all it is reversed, you try to parse each string as a JSON object, and within this JSON object, you can have a very long base 64 strings. So when you try to decode them, you can have another file. This file can be a zipped file, and when you uncompress it, you will see a Windows midi-dump file. So it is a crash format for Windows in Android, which is Linux. So it's kind of weird. You can open it with WinDBG. And after all these requests are reversed, you list all the variables and their content. And you can have a big picture of what it is sent. So, in fact, almost all configuration of your phone is sent. Especially the lock pattern on your phone. So if you have a lock pattern and the size of the lock pattern. All the security settings and even weird things like the sound you use to wake up, the sound you use for notification and call, and the usual tracking user info. So each time you click somewhere, it sends a timestamp for this action. Let's continue with the banking application. So we have analyzed all these applications, and the red one are the one we will present you. Here is a comparative statistics about American and European application and Asian application. So just to be quick, because I lack time. Banking application use lots of permissions. So if the application is vulnerable, the attacker does not even need to run a root exploit, because the application have already a large permission on the phone. And between European and American and Asian mobile banking application, the differences is the application from Asia use a little more permissions. From when we do statistics on behavior, this is a narrowed list of the behavior we detect. Just what we can say is almost all applications load their content from the web. So when I say load their content from the web, I mean they load their interfaces within WebView class. So within a WebView class, you can call JavaScript. And if the URL used to load the content is an encrypted URL, you can change the JavaScript to trigger some vulnerability. So, especially with the add JavaScript interface, which is an interface for controlling Java function from JavaScript, and lots of Android phones are vulnerable to a particular vulnerability that an attacker can call any function from the JavaScript. So, like, excuse me, as the mobile banking application use all the behavior that are susceptible to trigger vulnerability. we had to carefully read the code of each one. So, Asian application seems to be more aware of security problems than European and American application. In fact, we've seen more use of custom obfuscation, for example, encrypted code decrypted and executed on the fly, and custom list of SSL certification authority. So it was much harder to analyze this application because with the custom list of certification authority, it blocks our dynamic analysis tool. So I will show you some what we found in all ASEAN mobile banking application we have analyzed for this talk. You see 50% of the application use fake certification authority countermeasure. So our tool was unable to get the content of HTTPS request. So in fact, in 50% of the case, we had not dynamic analysis data. We are thinking to improve our tool to bypass this countermeasure. We have found two vulnerabilities in the Bank of China and in State Bank of Mongolia, and we are presenting you the Bank of China vulnerability. Okay. So the first case is the application from JP Morgan. What is interesting here? We receive a string in a JSON object here. And the variable name is signature. So at first, it seemed really weird to have a so long signature. So maybe it is encrypted data. The next thing we've done, we use a tool called API Monitor that instruments the application. So it reverses the application, add monitor function around targeted function. We targeted all deciphering function. Then it compiled it into a new application. So when you execute this application, it dumps on the logcat the argument of the targeted function. It's what we done, and this is what we get. So the first one is the signature string, which is received from the web. And just after this receiving this string, deciphering method is called. We are able to get with API Monitor all the parameter and the return value. So it is a list of ASCII character value in decimal. So with just a little scripting here, we can reconstruct the string, and this is what this is the string after deciphering. So in fact, it is a string. There are several strings in this string. We have a recurring pattern to parse the string. The two first one seems to be signature, but the third one not seems to be signature. It is in fact a list of application that use root right. So our guess is that the JP Morgan search for application that use root right. So when it detects it, it means the phone is rooted. But the string is cut because there are limitations in the log cut. You cannot print as character as you want, but it is not a problem because we have the recurring pattern. And with this recurring pattern, we can search in the code source, in the reverse code source, where it is used. So it's what we've done. And this is a subset of the code that parse this string. And in fact, a part of this string is sent directly into a shell command. And this is a part of the verification procedure from JP Morgan. They execute some shell commands on your phone dynamically to see if you have been infected by a malware. But the problem is this is a remote shell because these shell commands are executed on the fly. So a remote shell in an application must be considered as a backdoor because if JP Morgan wants, it can send arbitrary shell commands. So it can control your phone through the application if they want. They could have done it differently. For example, loading this command from an encrypted asset, but this is not the way they did it. The vulnerability is still there. It's not a vulnerability, it's a backdoor. It's still there since we have presented it in last December in the CCC. The next case is the BNP application. So BNP is a bank from France. It's a major bank. Here is the panoptic graph of the application. We are unable to get the HTTPS content from the application to the BNP server because BNP embed their custom list of certification authority just for the connection with their server. So I can get the content, but this is not a problem because the vulnerability we found is in an unencrypted communication. So this is a server address from companies that deliver hardware. BNP use it for its own advertising within the application, so additional service, sort of thing like that. And no, it's not this one. Not this one. Sorry. So there are a problem. Okay, sorry. There is a problem on this one. In fact, I think I switched the name. It is another bank. So I don't know what I know. Maybe. Sorry for this. No, it's there. Okay. Okay. So we receive an HTML document that is executed within a web view. So this is a JavaScript. This is a JavaScript, and this function does not seem to be in a regular library, JavaScript library. So we thought it maybe was JavaScript interface. And so we search for this string in the reverse code source, and we get a JavaScript interface. So as it is used in plain text communication, an attacker can modify it to execute custom JavaScript on the phone, and a large portion of the Android market is affected by a vulnerability, and this vulnerability the attacker can call arbitrary function on the phone, so it can own your phone. So with this vulnerability, anyone doing man in the middle can own your phone. I looked for this application just before the talk, and the vulnerability was still exploitable, but it is very easy to correct it. You just have to change HTTP to an HTTPS. So in the next case, I am going to talk about a problem that affects a lot of the mobile world through the Sberbank application. So Sberbank is a Russian bank. And this application send interesting strings to their server, to Yandex Maps server. So this is the MAC address of my custom access point that I use to do SSL man in the middle. And this is the list of all surrounding MAC address and their strength for signal strength. So the application send continuously or dump all the Wi-Fi that are around the phone. So it may be weird, but in fact Google Maps do it too. So when you examine the request where it is used, so this is one of this request. So it sends all Wi-Fi networks, and when we get the answer, is phone by Wi-Fi, and it sends coordinates of something. So it is in fact geolocation, and when you are indoor, your GPS signal is not good, so the application sends all the surrounding Wi-Fi networks, and the server can send you your coordinate. It means that this server, Yandex Maps, know your Wi-Fi location. But as it is in France, in my laboratory, I don't think that any Yandex, someone from Yandex came here to locate all my Wi-Fi networks. So how the application, how they get this location. And it means that Yandex, as well as Google, have an extended database of worldwide Wi-Fi networks with their location, so personal and companies' Wi-Fi networks as well. And in fact, your phone is doing while driving. So if you are not familiar with while driving, it's a concept where you are in your car and with your laptop, and you go to your turn, and you get the location of all Wi-Fi that are surrounding. But in this case, is your phone that is doing this process. So every time you work with your phone, the application is constantly sending the surrounding Wi-Fi networks. And when the server has 3 positions for one Wi-Fi networks, he can triangulate it, so he can get his location. And so every time you have an Android or as well as an iPhone, and you use Google Maps, that is installed when you buy it, or if you use Yandex Map, it do it all the time when you use your phone. In fact, you have an option to uncheck, that is enabled by default. So you need to uncheck this option in a location that send all surrounding Wi-Fi networks, if you don't want that your Wi-Fi will be on the Google or another company server. So if you lose your Wi-Fi, just call Google. The next case is a bank from Brazil. It's Bradesco. So what is interesting here is the communication with a server in plain text. And the application asks a key to the server, and the answer is obviously okay. No, it's not this communication, sorry. It's, yeah, so the server answer a key, but it is a private key. So this key is used for additional service, but it's also used in ciphering procedure to add a layer of protection on your credential when you connect. So in fact, there are no additional layer of protection because this key is received in plain text. So this vulnerability does not give an opportunity to an attacker to exploit the phone, but in fact, it could be used to do social engineering because additional services of the bank use it. And also the application embeds the jQuery JavaScript, which is used in the web view. So to not load this library from the web, it embeds it. But the problem is that the version embedded is very, very obsolete. So it contains vulnerabilities that are listed in the vulnerability database. I don't remember the name, excuse me. CVE. So the last application is the Bank of China. The application, the problem here the application check for updates. So the application check for updates, and it sends a command to the bank server, and okay, this one. So the server, so okay, it sends a request on the server that check the version update. So it's send is application version here, and the server answer a JSON file. And if we look at this JSON file, the server send a link to the Google Play to download the new application. So this download link is in HTTPS, but in fact, the verification procedure is done in plain text. So if an attacker can change this JSON file and change the URL and especially the package name to fool the user to download another application that could seems to be the application from this bank, but which is not. So in fact, it could fool a user to install a malware because this is done in plain text. So lots of problems are triggered by communication doing plain text requests. So a rule to apply when you develop it's always use SSL, because you don't know all the problem you can have when you use an encrypted text, an encrypted communication. So an attacker can fool the user to install arbitrary application, but also the application asks the server for links to display information in the application, and these links are in this procedure is done in HTTP, so an attacker can also change these links to display another thing. So it can exploit the confidence the user have in the bank to do whatever could be moneyable. So here is the type of answer we get from the banks when we have an answer. So we send them a report that explains what we have found and what could be the thing it can do to correct the problems. Here, this bank, the application from the bank was not vulnerable to anything, but we gave them the report, and the answer is a link to their web page, which talk about security in the mobile banking application. So it is so the bank does not always are not always very happy to talk with us, and when we have an answer. So now we wait the bank to contact us, and if they want the detail of what we found on their application, we send them. And but we expect them to change the problem, to correct the problem. So we intend to analyze lots of applications not just mobile banking application. Moreover, we are thinking to publish all our reports that we've done when the application have been corrected. I am starting actually a PhD and one of its objectives is to finalize all the prototypes we've designed and to add more mathematical algorithm to automatize the analysis, to have a fine-grained analysis, because malware detection is just a part of the problem, and you can't limit yourself to malware detection. You have to check for vulnerabilities, for data leakage, user tracking over user tracking. So, and the last thing is, as an IT engineer and security researcher, we need to pressurize the developers to on the subject of user privacy, because lots of time the developers to get money they dump lots of personal data to monetize their application, to optimize the monetization. So, and it is massively appearing, and we need to know about that, the first thing, but we need to pressurize the developer to not doing it by revealing what is really done, as I have done with the Facebook application. So when I say to not send personal user information, I do not mean sending anonymous information, because this is also information that are used to do massive social engineering, to get more money from their user. So all the information that are not related to the application functionality should not be sent. Oh, sorry. So when, what alternative do we have? When it is possible, use open source application, because when there are a problem on this application, generally the problem is rapidly corrected. And when you install a bank application, try to use a local bank instead of an international bank, because international banks tend to have more problem. It's not all the time the case, but international banks tend to do more user tracking than local bank also. Thank you for your attention, and now you can ask me questions and I will answer you. Yeah?
First of all, thanks for the presentation. I think it's a very common problem for big vendors and banks to ignore penetration testing reports. That also happens to us. First of all, do you plan to publish follow-up tests?
When it is finalized, it will be a matter of discuss with all the person implied. Can you repeat, please?
How do you handle certificate pinning in Columbus? Because, well, for us, when we do penetration tests of mobile applications of banks,
Can you?
Certificate pinning.
Yeah.
It's like.
Because maybe I know it, but in other words.
Yeah, I mean that you cannot do simple many-link attack just by
Yeah.
putting the certificate.
Yeah. There are countermeasures like. Yeah. But the next thing is you have to instrument the application or the system where this application is used. And instrumentation, so I know a little the matter, it's a little less stable. So you will have lots of problems, but it will always bypass all the security measures because when you instrument the kernel or its own application, you can bypass all this feature.
Okay, and the last question. The device which was hidden under the shell, does it need rooted phone?
I'm sorry because I have not designed this tool, so I could not detail you how it is make. But if you send this question to Eric Fiol, he could answer you. But I cannot answer you on this. I'm sorry. Thank you. Another question? Thank you.